So good evening all. Good evening ma.
Good evening, sir.
Anyone today attended JEE exam?
No, sir.
No. So Samhita, when you are having JEE exam, Samhita J?
8th, sir.
8th,
9th.
9th. Okay. So actually yesterday sessions I had seen some paper. Okay. Some repeated questions also they're asking the exam. That is the one hint I can give you. Some repeated questions are there in I told you na already previous papers better to go for the some MTG previous years, Arihant Arihant previous years also it is there. Okay, from that directly one question it is repeatedly it came. So at least once you revise that one means you will get some idea. Every time I'm telling that, but I don't know how many members you are following. And I forwarded some previous years also 43 years I posted in group. It is JE level, JE at advanced level it is there. Check it out, ma. Okay, clear? And last class we studied, we are discussing about here hydrogen bonding. Okay, so how many types of the hydrogen bonding it is there? How many types of the hydrogen bond it is there, ma? We have two types of the hydrogen bonds. What are the two types of the hydrogen bonds are there? So one is intramolecular hydrogen bonding and another one is intermolecular hydrogen bonding. Sir, what is with the intra means here? The hydrogen bond which is present in within a molecule is called as a intramolecular hydrogen bonding. Okay, the hydrogen bond which is present in between two molecules, is called as here intermolecular hydrogen bonding. Okay, and here two molecules are there, ma. So one more question it is that. So actually what I told here, hydrogen fluoride and water molecule it is that. Hydrogen fluoride, water molecule. Actually, electronegative atom is going to be increases means hydrogen bond strength also is going to be increases. Electronegativity is going to be increases means here their hydrogen bond strength also is going to be increases. Sir, why the hydrogen bond strength is going to be increases means because of it has a strong intermolecular attraction forces. While having the strong intermolecular attraction forces, okay, it has a high hydrogen but strong hydrogen bond. Okay, now my question is, sir, if you compare with the fluorine and oxygen, fluorine is more electronegative atom. So that means fluorine is having the highest highest bond strength, or is hydrogen fluoride is having the highest boiling point temperature. Now my question is, we are comparing the boiling point temperature. Either hydrogen fluoride is having the high boiling point temperature, or water is having the high boiling point temperature. Niharika, Samhita J, Srita. So which one is having the greater the boiling point temperature? Now water is having greater boiling point temperature while comparing with the hydrogen fluoride. Sir, hydrogen fluoride is more electronegative than that of the oxygen. But water is having high boiling point temperature. Sir, why the water is having the high boiling point temperature means water is boils at 100 degrees centigrade. In this one, each water molecule it forms as a 4 hydrogen bonds. Each water molecule it forms as a 4 hydrogen bonds. How many hydrogen bonds it is going to be formed means here? It forms as a 4 hydrogen bonds. One water molecule it forms as a 4 hydrogen bonds. But in this one hydrogen molecule, it forms only one hydrogen bond only. One hydrogen bond it forms as a one hydrogen bond only. One hydrogen fluoride it forms only one hydrogen bond. But one water molecule it forms as a 4 hydrogen bonds. Okay, so which one is required more energy to break the bonds? Water only, na? So water is having high boiling point temperature while comparing with the hydrogen fluoride. Got the clarity? So
yes, sir.
Okay, so which one is having the high boiling point temperature means water is having the high boiling point temperature. Why the water is having the high boiling point temperature means due to each water molecule it forms as a 4 hydrogen bonds. Okay, so next. So what is the another big concepts we are having means exam point of view concepts we are having means here actually next valency bond theory is there, hybridization is there, VSEPR theory is there, and dipole moment. Sorry, first I will discuss about the dipole moment. Okay, dipole moment. So what is meant by the dipole moment? How you are going to represent the dipole moment? It is also one of the important point here. So dipole moment can be represented with mu. So how you are going to represent the dipole moment, ma? So dipole moment can be represented with mu. So mu is equal to, so charge into distance. Mu is equal to charge into distance. Okay, mu is equal to charge into distance. That is only we can call as a dipole moment. Sir, how we can define the dipole moment? Dipole moment can be represented with mu. Okay, mu is defined as it is the product of the charge and the distance between two poles. Are what is meant by the two poles? Two oppositely charged ions. The distance between two oppositely charged ions is called as a dipole moment. Okay, so dipole moment is the vector quantity. Dipole moment is the vector quantity. Okay, how we are going to represent the dipole moment means dipole moment can be represented with cross-headed arrow mark. How we are going to represent the dipole moment? Dipole moment can be represented with cross-headed arrow mark. In this one, arrow mark is represented as a more electronegative atom, and cross symbol is represented as an electropositive atom. Okay, so arrow mark is represented as a electronegative atom, and cross symbol it represents as an electropositive atom. Okay, polyatomic molecules. In polyatomic molecules, how we are going to calculate the resultant dipole moment means mu r is equal to, for example, I'll give one example here. Triatomic molecule is there. So general triatomic molecules means we can write as a B, C I'm taking here. In this one, central atom I'm taking as A. A is connected with B. At the same time, A is connected with C also. A is connected with B. A is connected with C also. Okay. In this one, in between the B and C, whatever the angle it is that we can call as a bond angle. What is with the bond angle? Bond angle is nothing but the angle which is present in between two bonds is called as a bond angle. Okay. Now, in this one, this we can call as a mu1 dipole moment. Okay. And this we can call as a mu2. These two atoms, what are the dipole moment is that dipole moment is that we can consider as a mu2. This we can call as a mu1. So based on that one, whatever the bond angle it is that we are going to consider as a theta. According to that one, how we can write as a mathematical expression means the resultant dipole moment mr is equal to square root of mu1 square plus mu2 square plus 2 into mu1 mu2 cos theta. So by using this formula, we can calculate the dipole moment in a polyatomic molecule. Okay, so by using this formula, we can calculate the resultant dipole moment in a polyatomic molecule. But formula based and at all, they are not asking anything. They're not asking anything. Simply, which type of question they're asking means here, which one is having the greater the dipole moment. Okay, so what is the question they're asking means some previous year question it is that I'm going to be explained here. Okay, so here, first of all, let us see. So better we'll see the applications of the dipole moment. Then we can go over the questions here. Applications of dipole moment. So what is the main importance of the dipole moment? So based on the dipole moment, we can say either the given molecule is planar or not. Okay, so dipole moment can be explained whether the given molecule is planar or not. What is another one means here? So either the given molecule is, it explains either the cis isomer or trans isomer. Okay, so based on that one we can say here whether the given molecule is cis isomer or trans isomer. Okay, so and we can explain the geometry of the molecule also. We can explain geometry of molecule. Sir, what are the examples all for this one means here? Let us see, sir. Okay. Here some examples are there. According to the dipole moment, the planar structure, the molecules which are having planar structure or linear structure, for them dipole moment mu is equal to 0. Okay, the molecules which are having planar structure or linear structure, for them the dipole moment is equal to 0. Sir, what are the examples for that one means here? BF3, and BeCl2, it is that BeCl2, and carbon dioxide also. Okay, so all these are the different examples. In BF3, what is the hybridization of the boron? Any one of you? Do you have any idea? What is the hybridization of the boron? What is the hybridization of the boron? So boron, it exhibits as a sp2 hybridization. Which hybridization ma? It exhibits as a sp2 hybridization. Okay, in this one central atom is boron. So each boron is connected with the 3 fluorine atoms. Each boron is connected with the 3 fluorine atoms in a trigonal planar manner. Okay, they connected with the trigonal planar manner. So whenever it is having the planar structure, mean in this one, what about the dipole moment? Dipole moment, it becomes as a 0. Okay, and BeCl2, sir, beryllium chloride. So what is the structure of the beryllium chloride? Means they're having the linear structure. What is the hybridization? Means sp hybridization. Whenever they're having the sp hybridization, means they exhibit as a linear structure. Okay, now in beryllium chloride, so we can explain the dipole moment. Dipole moment is nectar quantity, means we can represent as a crossed symbol only, na? In this one, if you compare the beryllium and chlorine, which one is more electronegative atom? In beryllium and chlorine is more electronegative atom. So that's why arrow mark I wrote towards to the chlorine atom and positive symbol towards to the beryllium. And similarly in this also, now if the vector quantity is present in opposite direction or same direction?
Different directions.
So exactly opposite direction. It's not the different direction here. Exactly in opposite direction. So whenever they're present in exactly opposite direction, net dipole moment, it becomes as a 0. Okay, so wherever you're getting as a 0 dipole moment means the molecules, it may be having linear structure or planar structure. Okay, so what is the structure of the carbon dioxide? What is the structure of the carbon dioxide? In this one, carbon dioxide also it is having linear structure. Carbon dioxide also it is having here linear structure. Okay, it is also exhibit as a sp hybridization. Okay, this is the one concept. And what is the second statement I am giving here? So based on the dipole moment, we can say whether the given molecule is exhibit as a cis isomer or trans isomer. Sir, where you studied about the cis isomer and trans isomer? Cis isomer and trans isomer. Where you studied about the cis and trans isomer? Where you studied about the cis and trans isomer, ma? Geometrical isomerism, do you studied or not? In alkenes?
Yes, sir.
Okay, so cis and trans. When we can call as a cis and when we can call as a trans, ma? Cl, bond Cl, here also H, here also H, it is there. Okay, and one more I can write as here C double bond, here also Cl, here also Cl, bond H, bond H. Now in this one, which one is the cis and which one is the trans? Which one is
The left one is cis and the right one is trans.
The left one is the cis and right one is the trans. Very good, ma. Okay, sir, how we can explain the cis isomer and trans isomer? Means if the identical atoms are present at same side of the double bond. Okay, if the here identical atoms are present at same side of the double bond, means that we can call as a cis. Okay, if the identical atoms are present at opposite side of the double bond, mean that we can call as a trans. Okay, so what is meant by the cis means here, if the identical atoms are present at the same side of the double bond, mean that we can call as a cis. If the identical atoms are present at opposite direction, mean that we can call as a trans. Okay, now in this one, once you check it out here, sir, how we can explain the dipole moment means we are applying the vector quantity. If you compare with the carbon and hydrogen, which one is more electronegative atom? Carbon only more electronegative, na? So arrow mark we are going to write towards to the carbon atom. And if you compare with the carbon and chlorine, if you compare with the carbon and chlorine, which one is more electronegative atom means chlorine is more electronegative. That we are representing like this. Okay, and here also. So this one is, so this side we can write and this side also we can write. So vector quantity is present in same direction or different direction? Vector quantity is present in a same direction. When the vector quantity is present in the same direction, that means mu is equal to 0. If sorry, mu is not equal to 0 because of these are present in the same direction. Arrow marks are that moving in the same direction. They are moving in upward direction. Whenever they are present in the same direction, means that time mu is not equal to 0. Okay. Now in the second one you can compare. Second one, if you compare with the carbon and hydrogen, carbon is more electronegative atom. Okay, so carbon we are writing as like this. And here also carbon and hydrogen, carbon is more electronegative atom, we can represent like this. And if you compare with the carbon and chlorine, which one is more electronegative? Chlorine is more electronegative. Okay, and here also what we can write as here, chlorine is more electronegative. Okay, now vector quantity is present in same direction or opposite direction? In both the cases.
Opposite.
Opposite. So what I'm telling that when of the vector quantity is present in opposite direction is mu is equal to 0 na? Mu is equal to 0 only na? Okay. Now which is having the dipole moment is equal to 0 means in trans isomers dipole moment it becomes as a 0 and cis isomers dipole moment is not equal to 0. Got the point?
Yes,
Got it
sir.
all? Okay, and here one more it is that. So what is another structure means here? Now some question of that. So what is another one means here? If the electronegativity is going to be increases, dipole moment also is going to be increases. For example, I'm giving as a NH3. Based on NH3 also one more question it is there. So which is previous JEE question. NH3, NF3. Which one is having the greater the dipole moment? That is the question. And they asked in the sentence formation. Why it is having greater the dipole moment? They're asking reason. Actually, JEE question here. Okay, first of all, what is the question? In ammonia and trifluoroammonia, which one is having greater the dipole moment? Point number one. What is the reason? What is the reason? Assertion reason type question they asked.
Sir, I remember it being NH3.
Why the NH3 is having greater the dipole moment? Exactly, Ms. Amita. Very good answer.
I don't know
Very
why. I just remember from 11th that it was NH3.
Okay, so let's see. First, I'm writing as a structure. Both are exhibiting as a sp3 hybridization. Both are having pyramidal shape only. Both are having pyramidal shape. Okay. Now, here also once you observe here also fluorine, here also fluorine, here also we're having fluorine. Each nitrogen is having one lone pair of electron. Here also we're having one lone pair of electron. Okay. Now, if you compare with the hydrogen and nitrogen, which one is more electronegative means nitrogen is more electronegative. Here also nitrogen is more electronegative. Here also nitrogen is more electronegative. Now, here if you compare with the atom and lone pair of electrons are more electronegative. Okay. Now, second structure I am going to be observed. If you compare with the nitrogen and fluorine, fluorine is more electronegative. Nitrogen and fluorine is more electronegative. Fluorine is more electronegative. Okay. And in this one, electrons are more electronegative. Now, what's the difference it is there? What's the difference in the vector quantity in ammonia and trifluoroammonia? Samgita.
What, sir?
what's the difference it is there after writing the vector quantity? After representing the vector quantity, what's the difference you are
H
observing?
is towards N and F is away from M because F is more electronegative.
Very good. So vector quantity is now in NF3. You are observing that vector quantity is present in opposite direction. Is it right? In this direction, one switch to do here. In this one, vector quantity is present in opposite direction only. Na? In a vertical line, you can observe. Ma. In a vertical line, also vector quantity is present in a opposite direction. So both the direction it is opposite means then mu is equal to 0. But in this one, what happened? Vector quantity is present in the same direction. When the vector quantity is present in the same direction means mu is not equal to 0. Okay, vector quantity is present in the same direction means here mu is not equal to 0. Okay, clear? You got the clarity or not?
Yes, sir.
Okay, now which one is having the greater the dipole moment, ma? Ammonia is having the greater the dipole moment. Okay, so which one is having the greater the dipole moment here? Ammonia is having greater the dipole moment than that of the trifluoroammonia. Got the clarity? You got the clarity or not, ma?
Yes, sir.
Okay, next. And one more question, one more previous year question, ma. Here, first I'll write simple question. In hydrogen fluoride, water molecule and ammonia. So which one is having greater the dipole moment?
Sir, NH3.
No, ma. Electronegativity is going to be increases. Dipole moment is going to be increases. Electronegativity is going to be increases means dipole moment is going to be increases. Got the clarity?
But for NH3, dipole moment is not 0, right?
Where, ma? Answer is in all these cases dipole moment is not equal to 0 only.
Yeah.
Okay, but which one is having greater the dipole moment? In all the cases also dipole moment mu is not equal to 0. And which is having the greatest dipole moment means based on the electronegativity. Electronegativity is going to be increases that it has a greater the dipole moment.
Sir, but for N have F3, right? Like, why isn't the dipole moment not more than NH3?
Not more than NH3 means here in NH3, if you draw the structure means vector quantity is present in opposite direction. Na? Let us see, first we wrote as a NF3. This is the and this F it is
But
there.
then NF3 is more electronegative than NH3, right?
Of course, electron that is what I am going to explain here. Based on the electronegativity only, we are writing as a vector quantity. Now, in this one, arrow marks are present in opposite direction or same direction.
Opposite direction, sir.
Whenever it is present in opposite direction, means mu is equal to 0 only. Na? Got the point or not?
Yes, sir.
Okay, and one more also, let us see here. Here also lone pair of electrons are there. Here also one fluorine atom is there. Vector quantity is present in opposite direction. When the vector quantity is present in opposite direction, then it becomes as a mu is equal to 0. In this one, what happened? All are present in the same direction. Whenever it all are present in the same direction, that time it is mu is not equal to 0. Got it? Here also, we wrote hydrogen and nitrogen. In hydrogen and nitrogen, which one is more electronegative? Nitrogen only, na? Here also we explain the electronegativity. Okay?
Yes, sir.
Right, ma. And one more question, ma. Previous year question, just I will explain you here. So, methane is it undergoes the chlorination reaction which forms as a methyl chloride CH3 Cl CH2 Cl2 and CH Cl3 and CCl4. So which one is having the greater the dipole moment? Okay, so which one is having the greater the dipole moment means methyl chloride, after that dichloromethane, after that chloroform and tricarbon tetrachloride. Carbon tetrachloride is having the 0 dipole moment. So based on this one also they're asking the question. Okay, based on this one also they're asking the question. Okay, and what is the next one means here? Some hybridization concept it is there. Based on the hybridization also they're asking the questions. Based on hybridization, they're asking the questions. Sir, hybridization, we are going to explain BBT, valency bond theory. Okay. Valency bond theory explains the formation of the bond. Okay. How the bonds are going to be formed. Okay. If you see means we have two types of the bonds. One is the sigma bond, another one is pi bond. How the sigma bond is forming, how the pi bond is going to be formed. Any one of them, according to the VBT. According to the VBT. So what is mean by the sigma bond? And what is mean by the pi bond? So how is the sigma bond is going to be formed? How the sigma bond is going to be formed? Ma? What is mean by the sigma bond? Sigma bond is formed by the linear overlap. Okay, sigma bond is formed by linear overlap. Pi bond is formed by side to side overlap. Side to side overlap. Okay, sigma bond is formed by the linear overlap. Pi bond is formed by side to side overlap. In this one, sigma bond is strong bond. Sigma bond is here, strong bond. Pi bond is weak bond. Okay, and sigma bond is called as a localized bond. Localized bond. Pi bond is called as here delocalized bond. Delocalized bond. Pi bond is called as a delocalized bond. Okay, and here pi bond is formed after the formation of the sigma bond only. Pi bond is formed. Pi bond is formed after the formation of after the formation of sigma bond. Sigma bond. So this one, greater the extent of the overlapping, greater the bond strength. Okay, so greater the extent of the overlapping, greater the bond strength. Okay, so for this one, they had given bond strength also. So p orbital is greater than p orbital, s orbital. After that, s orbital, s orbital. So this is the extent of the overlapping. Okay, so based on this one, I had given some previous year questions that I'm going to be discussing. Here, tetracyanoethylene. The total number of sigma bonds and pi bonds present in a tetracyanoethylene. Sir, what is the molecular formula of the tetracyanoethylene? Means C2CN taken 4 times. C2CN taken 4 times. C2CN taken 4 times. Sir, the total number of sigma bonds and pi bonds. So to find out the number of sigma bonds and pi bonds means first we have to know the structure. Na? First either we have to know the structure or not. Okay, now let us see, sir, how we can draw the structure. Means C double bond C bond, C triple bond, and here also C triple bond, and here also C triple bond, and here also C triple bond, and so can you calculate the total number of sigma bonds? Wherever the double bond it is there, in that one is the sigma bond, another one is pi bond. Wherever the triple bond it is there, in that one is the sigma bond, another remaining two are pi bonds it is there. Okay, here sigma bond and two pi bonds. Here sigma bond and two pi bonds. Here sigma bond and here two pi bonds are there. In a triple bond, we have a one sigma bond, two pi bonds. In double bond, one sigma bond, one pi bond. Okay, so based on that one, can you calculate the total number of sigma bonds and pi bonds? It is also one of the previous year question. It is also one of the previous year question. Any one of you? Sometimes they ask a ratio also. What is the ratio of the number of sigma bonds and pi bonds? Check it out, ma. Any one of you? No one is giving the answer.
Sir, 9 pi and 9 sigma.
Very good, ma. 9 pi, 9 sigma bonds and 9 pi bonds, ma. That is the correct answer. That is the correct answer. What is the ratio?
1:1.
Very good, ma. Okay. Very good, ma. So 1:1 is the ratio. Okay. Now, so 1:1. Still anyone you having doubt? How you got as a 9:9? 9 sigma bond and 9 pi bonds. The ratio is 1:1. The ratio is here 1:1. Still anyone you having doubt?
No, sir.
No, na? Niharika, Samhita. Okay. Ma. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma bonds. And where are the triple bonds? That here 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 2, 7, 7 plus 2, 9. 9 is to 9 is the answer. Okay. Then, so based on this one also we're having some of the percent. So based on number of sigma bonds also we can explain the hybridization. Based on the number of sigma bonds, we can explain hybridization. Hybridization. Sir, what is mean the hybridization? What is the main importance means here? Intermixing of atomic orbitals is called as a hybridization. The intermixing of equal energy of atomic orbitals is called as a hybridization. So what is the main importance of the hybridization means here? So hybridization is explains geometry of the molecule, bond lengths, bond angles. Okay, so all is going to be explained by the hybridization. You got the point here? Hybridization is going to be explained here. Geometry. Geometry is nothing but shape of the molecule, and it explains the bond lengths, and it explains the bond angles, and it explains bond orders. So bond orders generally we can consider here. So we can explain the bond length. Okay, bond angles are going to be explained by the hybridization. Okay, so we have a different types of the hybridization. So what are the different types of the hybridization with respect to the number of sigma bond? If the molecule is containing all 6 sigma bonds, how many sigma bonds, ma? If it is having 6 sigma bond, if it is having 6 sigma bonds means, okay, it exhibit as a sp3d2 hybridization. Which hybridization is going to be explained? sp3d2 hybridization. Okay, if it is sp3d2 hybridization means, now let us see, it exhibit as an octahedral shape. Exhibit as here octahedral shape. Sir, what is the best example for this one means here? SFCs. In this one, central atom is sulfur. Okay, 4 fluorine atoms are present at 4 corners of the sulfur. Okay, and one fluorine is present above the plane, and another fluorine is present at below the plane. Okay, sir, if you compare this one means here, okay, if you compare, so these bonds are we can call as a equatorial. This we can call as a axial. Okay, if you compare with the bond length between the equatorial sulfur and fluorine, okay, is less than that of the bond length of sulfur and fluorine of axial. Sir, why it is having the greater the bond length means? So when they come close together means they are having the repulsions. To overcome that one, they occupy the more space. That means the distance between the sulfur and fluorine is going to be increases. That time bond length also is going to be increases. So due to that reason only, axial bond length is greater than that of the equatorial bond length. Got it? You got the clarity, ma?
Yes, sir.
Okay. So what is the hybridization means here? sp3d2 hybridization. In sp3d2 hybridization, total how many sigma bonds are there means here? Total sigma bonds, 6 sigma bonds. If the central atom is surrounded by the 6 sigma bonds, means it exhibit as a sp3d2 hybridization. Okay. If it is having 5 sigma bonds, 5 sigma bonds, it exhibit as a sp3d hybridization. Sir, what is the best example for this one means here? PCl5. Phosphorus is the central atom. 3 chlorines are present at 3 corners of the trigonal planar. So 1 chlorine atom is present at above the plane. 1 chlorine atom is present at below the plane. Okay, so 1 chlorine atom is present at above the plane. 1 chlorine atom is present at below the plane. Okay. 1 second. Charting this. Is any bond angle? Can you expect in this one? What are the bond angles are exhibited means? Any one of you? What type of the bond angles are present in trigonal planar? In this also axial bond length are greater than that of the equatorial. Okay, so what type of the bond angles are there? We have a 180 degrees bond angle. At the same time 120 degrees bond angle it is there. 180 degrees bond angle and 120 degrees bond angle it is there. Okay, even in this one also 180 degrees it is there and 90 degrees bond angles also it is there. So where we can take as 90 degrees means the angle which is present between the sulfur and fluorine. Here we have a 90 degrees. Okay, and where we have a 180 degrees means fluorine, sulfur, fluorine. That means in this direction also you can take. Okay, in this direction also we can take. So 180 degrees bond angles are there and 90 degrees bond angles are there. In PCl5 we have a 120 degrees and 120 degrees bond angle and 90 degrees bond angles also it is. 90 degrees bond angles also we are having. Okay, and if it is having 4 sigma bonds, 4 sigma bonds will exhibit as a sp3 hybridization. 4 sigma bonds will exhibit as a sp3 hybridization. So what is the best example means? Methane. Okay, so methane means here central atom is carbon, here 1 hydrogen, here 1 hydrogen, here 1 hydrogen. It is having tetrahedral shape. It is having tetrahedral shape. What is the shape of this one means here? Tetrahedral. Okay, so this one is called as octahedral. This we can call as a trigonal bipyramidal. Okay, this is the tetrahedral shape. Sir, in tetrahedral shape, what is the bond angle means? 109 degrees 28 minutes. So what is the bond angle, ma? 109 degrees 28 minutes. Okay, if it is having 3 sigma bonds, if it is having 3 sigma bonds, it exhibits as a sp2 hybridization. Sir, what is the best example means? Now only we had seen BF3. In BF3, we wrote as a trigonal planar structure. Okay, in trigonal planar structure, bond angle is how much it is there? 120 degrees. And if it is having 2 sigma bonds, if it is having 2 sigma bonds, it exhibit as a sp hybridization. If it is exhibit as a sp hybridization, what is the example? BeCl2. Carbon dioxides are exhibit as a sp hybridization. What is the bond angle means? 180 degrees. It has a linear structure. That's here linear structure. That means the bond angle in between these two we can call as a bond angle. The bond which is the bond angle which is present in between two bonds is called as a bond angle. What is the bond angle of the BCl2 means? 180 degrees. So based on this one, they're asking the questions. Which type of questions they're asking means they're giving some examples. They're giving some examples. So which are having isostructural 4-5 molecules they are giving. 4-5 molecules they are giving and which are having isostructural. Isostructural means which are having similar structure. That is the question. Which are having similar structure. Okay. So that kind of questions are there. You have to find out that one based on the options. Okay, clear? Or which one is having the increasing order of the bond angle, which one is having the decreasing of the bond angle, isoelectronics pieces. Some questions are there based on these concepts. Okay, so remaining only molecular orbital theory is there in this concept.
Mama,
So
class went to know.
tomorrow I'm going to be finished that molecular orbital theory. Then I'll close this one. Sunday you are having test. So management is asking to conduct some test. Tomorrow, that means Sunday, I'm going to give some grand test. Niharika.
Sir, on
Niharika,
what topics?
Ma, whatever we discussed. Either,
Okay, sir.
can I give either only 2 chapters? It's up to you. How many chapters you are able to write? Because of we discuss about the periodic table and chemical bonding also. Sir, better to give only periodic table and chemical bonding. And 30 questions means I'm ready to give 30 questions. Sir, better to include all the chapters which we discussed, and based on that one, why you can't give some question paper means I'm ready to give all the chapters. It's up to you only. How many chapters I can give the test?
Sir, anything is fine.
Anything is fine. What about Niharika? How many chapters you are able to write?
2 and 3 chapters, sir.
Only 2 chapters. So Niharika, just you try your level best. Okay, how many you are able to write? Okay, don't worry about the result. Next, Samgita. So Samgita, I am also giving all the chapters here. Okay,
All as in all we did till now?
ma?
All we did till now, sir?
1 hour only, ma, duration.
No, that's okay. All the chapters we did till now, sir.
Yes, ma.
Okay, from basic concepts of chemistry till chemical bonding.
No, let us see. All chapters are on screen only. It is there. Some basic concepts of chemistry is there,
Okay, sir.
and redox reactions, solutions, electrochemistry, atomic structure, periodic table, chemical bonding. Okay, in chemical bonding, only one concept pending. Exam JEE level question here. Molecular orbital theory only pending. It is there. So remaining all main important concepts I covered for you. Okay. So tomorrow,
And
anyway,
sir, is this
tell me, Masaki.
is this JEE mains level or MSET level?
It's completely JEE level. Okay,
Okay,
based on
sir.
5 chapters. So once you try. So however the paper it will be that only I'm going to be give. Okay, what are the paper standard they're maintaining JEE level? That standard only I can give. Okay. I'm not giving
Okay,
any
sir.
advanced level question. Frankly, I'm telling that I'm not giving any advanced level question. JEE level questions only I'm asking here. That questions are, it may be help for KSET also. MSET also. KSET, MSET, TSET, Telangana set. Telangana Common Entrance Test. MSET means engineering and and MSET means here engineering and
Architecture.
architecture common entrance test.
Yes, sir.
Okay. So it's up to that standard only. I don't want to give more difficult paper to. Okay, to try your level best. Okay, ma. Sunday we are having test.
Okay, sir.
1 hour test. 1 hour you have to spend the time on that one. Try your level best. Okay. Right. So we'll
Okay,
continue.
sir.
We'll continue in the next test. Thank you all.
Thank you, sir.